We've been solving equations in two steps that have where you have to use both addition and subtraction as well as multiplication or division to isolate the variable. What we're going to be doing today is just one small step more complicated, and it's based on work that we've done quite a bit of in the past. The equations that we're going to be looking at look something like this. 9x minus 2x plus 6 equals 27. So first of all, you'll probably notice that the thing that looks different, I'm going to fix this 9, it's ugly. The thing that looks different is that we've got two terms that have the variable. And essentially, if you remember, we long ago learned how to combine like terms. These are like terms because everything is the same except the coefficient. So before we go about the actual solving, the first thing that you need to do is combine the like terms. Remember, the sign in front of the number, like here, and there is no sign here, so that makes it plus, is the sign of the number. You could always say add the opposite, but now that we're in algebra, I think it's simpler if you just get used to realizing that the sign in front of the number is the sign of the number. So 9x minus 2x is 7x, plus 6 is equal to 27. Now we're down to a kind of equation that looks quite familiar. Here's my variable. I'm always trying to isolate the variable, and what undoes something is its opposite. So I always, in two-step equations, first do the addition or subtraction. That leaves me that 7x is equal to 21, and now I do the multiplication or division. So x is equal to 3. And if you plugged that back into the equation, you'd see it was true. One thing I want to make clear before we go on is that although mathematically it would be okay to subtract the 6 first, once again, you are in Mary the Dictator's class, and in my class, I want you to recognize that you have like terms and that they need to be combined before you get down to our very simple equation that is here. That's really the big idea. However, there are some things that look a little more complicated, so I'm going to take you through some other examples so that we can practice. It's 10 minus x minus 3x equals 50. Okay, so clearly right now, one of the things that's more complicated is there are three terms with x. Secondly, these x's have no number in front of them, otherwise called a coefficient. So if you remember, if there is no number, that means there's 1. So -1 plus -1 plus -3 is -4. So I have 10 here minus 4 x's. That's how many negative x's I have. Here's a negative x. Here's a negative x. Those two give me -2. Oops. And 3 more. Mary. So, good thing I'm checking my work. 2 plus 3 is 5, not 4, is equal to 50. Now, here's my variable. I want to undo plus 10. Remember, if it's in front, that means it's positive. Minus 10 minus 10. So this is -5x is equal to 40. And now I divide both sides by -5, because when I'm dividing, I use the same sign, because that's what gives me 1. X is equal to -8. So don't forget, if there is no number in front, that means that the number is 1, and in this case, it's -1. All right, now, even more complicated is I have -5 minus 3/5 x plus 2/5 x is equal to 2. So let me put this negative sign up where it looks a little better. Okay, so here are my two x's, and fractions. One must remember how to add fractions, and in case you've forgotten, you add the numerators and the denominators stay the same. So I'm going to bring down my -5. -3/5 plus 2/5. So I'm going to add my numerators. -3 and +2 gives me negative 1, and that's over 5, because if I have fifths, if I'm adding fifths, if we're all positives, 2/5 and another fifth is 3/5. I know that you've done that quite a bit in the past, though my experience tells me that sometimes kids forget. So I need to do my addition or subtraction first. To undo negative 5, I add 5, because negative 5 and positive 5 is 0. Remembering that when I'm doing my additions or subtractions, I use the opposite sign. And when I'm doing my multiplication or division, I use the same sign. So this gives me 7. Now I need to get rid of this, so I'm going to multiply by a negative because I'm doing multiplication or division. And the 5 is what undoes that. I'm going to multiply by negative 5 here. So these two things become positive, and this gives me x equaling negative 35. So the thing to remember here is how to add your fractions. Sometimes they look a little bit tricky here, where you could say that 5/8 x minus, okay, so 5/8 x minus 3/8 x plus 12 is equal to 2. So 5 minus 3 is 2/8 x plus 12 is equal to 2. And you might say, wait a second, we haven't learned how to solve equations when the numerator is anything other than 1. But if you're paying attention, you'll realize that 2/8 is really 1/4 in disguise. Okay, now we've got an equation that looks quite familiar. So 1/4 x is equal to negative 10. I'll multiply both sides by 4, and I get x equals negative 40. One final example is if I have 4, let's see, no, x minus 4/5 x minus 8 equals 2. Okay, this combines two of the things that I was talking about with the little tricky twists. First of all, this is 1. One whole thing minus 4/5. How do we do that? Well, some of you might just be able to picture it in your heads, but 1, if I want to write it with fifths, is really 5/5 x minus 4/5 x minus 8 is equal to 2. So 5 minus 4 is 1. That leaves me with 1/5 x minus 8 equals 2. Add 8, and I get 1/5 x equals 10. Multiply by 5, and I have x equals 40. So that's how you solve equations with like terms.